Hello everyone, let's study Cauchy sequences in this particular session. Let's see the definition of Cauchy sequence. A sequence AN is said to be a Cauchy sequence if given epsilon greater than 0, however small, there exists a positive integer m such that mod of an minus am should be less than epsilon for all n greater than or equal to m. Or another definition would be a sequence AN is said to be a Cauchy sequence if given epsilon greater than 0, however small, there exists a positive integer m such that mod of am plus p minus am is less than epsilon for all p greater than 0, and this p belongs to our natural number n. Or another definition would be a sequence AN is said to be a Cauchy sequence if given epsilon greater than 0, however small, there exists a positive integer m such that mod of ap minus aq is less than epsilon for all p comma q belongs to m. Now let's study few theorems. The first theorem says every Cauchy sequence is bounded. Let us consider AN to be a Cauchy sequence. We will be taking epsilon is equal to 1. By definition, there exists a positive integer m such that mod of an minus m is less than epsilon, but here epsilon is 1, so we get less than 1 for all n greater than or equal to m. So when I remove the modulus sign, we would be getting am minus 1 less than an less than am plus 1 for all n greater than or equal to m. Let small k be equal to all the minimum values of a1, a2 and so on, am minus 1 comma am plus 1, and capital K to be maximum of these values a1, a2 and so on, am minus 1 comma am plus 1. Then this can be written as k less than an less than capital K for all an. This is nothing but the definition of boundedness. Therefore, sequence AN is a bounded sequence. Therefore, every Cauchy sequence is bounded. But the converse of the above theorem need not be true. That is, every bounded sequence need not be convergent. For example, an is equal to minus 1 raised to n is a bounded sequence, but it is not a Cauchy sequence. That is, when I say a bounded sequence, you get minus 1 less than an less than 1. Let's study Cauchy's general principle of convergence. A sequence is convergent if and only if it is a Cauchy sequence. Proof. Let us consider an to be a convergent sequence. That is, an converges to a limit value L. We have to prove that this an sequence is a Cauchy sequence. Let epsilon be greater than 0 be given, then there exists a positive integer m such that mod of an minus L is less than epsilon by 2 for all n greater than or equal to 1. Let's call this as equation 1. In particular, for n is equal to m, we have mod of am minus L is less than epsilon by 2. Call this as equation 2. Now let's consider mod of an minus am. So here what we are doing is, we would be adding and subtracting L. Then simplifying it, I will be grouping as an minus L minus of am minus L. And we all know that mod of x plus y is less than or equal to mod x plus mod y. So we get less than or equal to mod of an minus L plus mod of am minus L. And this is less than epsilon by 2 plus epsilon by 2 from equation 1 and 2. This implies mod of an minus am is less than epsilon for all n greater than or equal to m. Therefore, our an is a Cauchy sequence. Conversely, let an be a Cauchy sequence, we have to prove an is convergent. Since an is a Cauchy sequence and every Cauchy sequence is bounded, we get the given sequence an is bounded. And we also know that since every bounded sequence has a limit point, say L, And since L is a limit point of an, every neighborhood of L contains infinitely many terms of an. This implies an belongs to L minus epsilon by 3 comma L plus epsilon by 3 for infinitely many values of n. In particular, we can find an integer k greater than m such that ak belongs to L minus epsilon comma L plus epsilon. That is, mod of ak minus L is less than epsilon by 3. This is equation 3. Since k is greater than m and also an is a Cauchy sequence, we will use the definition. For a given epsilon greater than 0, there exists a positive integer m such that mod of an minus am is less than epsilon by 2 for all n greater than or equal to m. But k is greater than m. From equation 4, we have mod of ak minus am is less than epsilon by 3. Now, mod of an minus L is rewritten as, what we are doing here is we add and subtract am as well as we add and subtract ak. So we get mod of an minus m as one term plus am minus ak grouped as the second term plus ak minus L grouped as the third term. Using the property of inequality, we get this as less than or equal to mod of an minus am plus mod of ak minus am plus mod of ak minus L. From equation 3, 4 and 5, this is less than epsilon by 3 plus epsilon by 3 plus epsilon by 3, which is less than epsilon for all n greater than or equal to m. This implies an converges to L. Therefore, a sequence is convergent if and only if it is a Cauchy sequence. Let's study few problems. The first problem says, show that 1 by n is a Cauchy sequence. Let epsilon be greater than 0 be given for p greater than 1 by epsilon, and for all m comma n greater than or equal to p, we have 1 by m comma 1 by n obviously will be less than or equal to 1 by p, and this is less than epsilon. Therefore, mod of 1 by n minus 1 by m is less than epsilon for all m comma n greater than or equal to p. Therefore, 1 by n is a Cauchy sequence. Let's consider a second problem. We have to prove an is equal to n by n plus 1 is a Cauchy sequence. Let epsilon greater than 0 be given. Let n be greater than m. Let's consider mod of an minus am. That's equal to mod of n by n plus 1 minus m by m plus 1. Here what we do is, we would write n by n plus 1 as 1 minus of 1 by n plus 1 and m by m plus 1 as 1 minus of 1 by m plus 1. So 1 and 1 minus 1 gets cancelled. We are left with 1 by m plus 1 minus 1 by n plus 1, and modulus of that remains the same. And we know as n is greater than m, n plus 1 would be greater than m plus m, which implies after taking reciprocal, we would be getting 1 by n plus 1 is less than 1 by m plus 1. Therefore, mod of an minus am is less than 1 by m plus 1, that is less than 1 by m, and that is less than epsilon whenever m is greater than 1 by epsilon. Therefore, mod of an minus am is less than epsilon for all epsilon greater than 0. Hence, an is equal to n by n plus 1 is a Cauchy sequence. The references which I have used is a textbook of college mathematics by G.K. Ranganath, Sequences and Infinite Series by N.P. Bali. Thank you, dear students.